Hello everyone, and welcome to today's webinar on MLOps. So my name is Noor Basha, Marketing Director at Winwire Technologies, and I'll be a moderator for today's webinar. So as you all, most of you know, this is two-part webinar series. In the earlier session, we specifically discussed about securing machine learning at scale with Azure, basically focusing a lot more on Azure Databricks. In today's session, we will continue to discuss again securing machine learning at scale with Azure, with specific focus on Azure Machine Learning Studio and Azure Synapse Analytics. So in the next 45 minutes, what we will do is we will walk you through MLOps options on Azure, different tool sets, and how to get your modules into productions at the shortest time possible. So before we get started, let me highlight few housekeeping items. We are recording this session and we'll share the recording in next 24 to 48 hours. Okay, and during the webinar, please feel free to post questions and we will try to answer as many as we can at the end of the session. So with that, let me take this opportunity to introduce to our session speakers. So I have Pandian. Pandian heads our data and AI practice at Winwire Technologies, and he brings extensive experience in helping customers migrate, modernize, and govern data landscape on Azure. I also have Rabi. He's leading the data science practice at Winwire, brings close to 13 plus years of experience, especially in the data science and business analytics space. So with that, before we actually jump into the agenda, what we will do is we will just quickly take a poll, and I will have Pandian take the session from there. So you have 30 seconds to answer this poll, and we will go from there. Okay, 15 more seconds. Okay, 5 more. 5, 4, 3, 2, 1. Thank you. And what I will do is I will let Pandian take the session from here. Pandian, over to you.
Thanks, Noor. Good morning, everyone. Today, we will briefly look at initially to start with what is driving MLOps adoption, why people are looking at MLOps right now. So that's something we'll start very briefly, and then get to specifics in terms of how does Azure ML and Synapse help in building ML components. That's something we'll quickly look at, and then get into a demo how MLOps is built in these environments, and then follow it with a recommended implementation approach from Winwire in terms of our offering in MLOps. Right? So now let's before getting into it, we'll give a brief about Winwire. So Winwire is completely focused on Azure. We help customers adopt Azure to drive business growth and leverage and be how to be competitive in the market, right? Through our data-driven digital engineering expertise, and our Azure expertise has also been recognized by Microsoft through Partner of the Year awards, as well as winning the AIML Workathon. Right? And now to look at why we are talking about MLOps right now, right? So the need is there's a rapid increase in terms of enterprises evaluating ML solutions, and why they are doing it. The primary reasons are definitely availability of a larger set of ML software in the market, and the other major factor is AutoML, which makes things easier to build. In fact, AutoML has created a new user community called Citizen Data Scientists who can build model very quickly, right? And also we are seeing a lot of success has been seen ML in isolated business units. Now that is being looked at how that success can be replicated at the enterprise-wide. So there is a focus towards to make ML as an enterprise-wide initiative, right? And more MLOps, ML solutions are getting embedded in enterprise in transaction applications, right? So that's also one of the driving factor why a lot of focus is towards, because ML is getting into production systems, which will have a lot of impact, and there needs to be a good process defined how an ML environment can be managed, right? So this is also kind of reflected in one of the recent surveys which O'Reilly did, wherein we could see that there's a large percentage of enterprises currently evaluating and also moving towards production. So there is a more testing being done with ML solutions, which requires a greater focus, especially IT organizations and firms in firms are looking at how ML environments can be governed, managed, and scaled up. Right? And similar to what DevOps was adopted for standardizing the process of application software development lifecycle, MLOps is being looked at to standardize the ML lifecycle management. So to standardize, it brings in a process to automate those activities. So be it ML uh, model training or validation or deployment or monitoring, how all of this process can be simplified through automation. That's the core of MLOps, right? So now, if you have to look at specifically, since our interest is on Azure, how does ML applications get built in Azure? There are multiple ways which you could build an ML solution on an Azure environment, but primarily you could broadly look at four areas. One is using Azure ML toolsets, Databricks, and Synapse ML, and also you have a VM machine where you have all the libraries built as a service available for to build ML applications. Right? In fact, our part one was focused on Databricks, and now this part two will be focusing on Azure ML and Synapse. How ML ops can be brought into environment where customers are building ML applications using Azure ML or Synapse. That's the focus of this webinar. So whatever be the technology being used or tools are being used, the capabilities which has to brought into this environment remains the same. The ML capabilities which has to be addressed remains the same, and we can broadly classify them into data management, code management, and model management. So these are the 14 capabilities which has to be brought into an MLOps. So if you're building an MLOps processing your environment, you need to ensure these 14 capabilities are brought in. So in terms of data management, it's basically getting the data version, getting the data prepared, making it available for training and retraining process. That's the data management. The code management is you have the code scripts, models, developed configurations, how those can be versioned, how the metadata of those can be managed effectively. How do I understand the lineage of these different codes which are built? That's the second aspect. The third critical aspect is model management. So how do I register my model? How do I validate it? What are the different forms I could serve the model? How do I deploy it? And how do I monitor it? Right. So all of this capabilities, how do I bring in a flow? How do I automate all these 14 activities is what MLOps is. So in fact, an organization, how mature they are in MLOps adoption, right, could be looked at. If all of these 14 things are implemented, then highly mature, right? Out of this, 7 are implemented, then probably they're somewhere in midway. So this also helps us to determine where to start and what level we want to go in 6 months, and how do we achieve the full state of for complete maturity of all the 14 areas, right? That way also this can be looked at. And how these capabilities are delivered, there are various tool sets which can help us build those capabilities, especially with Azure ML. A lot of these capabilities are available within Azure ML. Then there are certain scenarios where we are going to use DevOps and then ML flow. In fact, we would see in the demo how all of these are coming together as part of the building an MLOps and for Azure ML or Synapse. Right. Now, let's specifically look at if I have to build my ML application using Azure machine learning, what are the different components available? Right. So what you see on the screen, we have an ML Studio which supports building, which has tools to build my model, to develop my model. I could take a designer approach, or I could write my code in a notebooks interface, or in fact, if I don't want to choose different algorithm parameters. The system itself can do it for me, the AutoML. And there are utilities like data labeling, which help me prepare my data, label my data. Right? So now, when I build a model, then when I have to run it, the run environment could be, again, there are two options Azure ML provides. One is the curated and the custom. So curated is, it comes up with popular frameworks like TensorFlow, is available setup already. Custom is where we could actually deploy our own libraries and then run the model which has been developed. So once the model has been developed, we could run in any of these environments. The next step is to take to the whole life cycle, right? In terms of how do I register it, how do I version the model, how do I put it to a container, how do I deploy them? So that's where I have to orchestrate the whole process of model management. That's where Azure ML provides a pipeline a capability which helps you to do this process of registration or version management. And there are two ways. There again, you have design approach, or you could use a command line interface or SDK based approach as well. And for deployment also, we have two options. There are multiple options, or in fact, we have four different options. How do I deploy as an endpoint, right? And for that, how do I choose my compute? So you could do it as a Kubernetes or local web service. And in fact, local web service could be more for testing activity. And if you are to move it to a production environment, then you would move for a Kubernetes kind of an environment. So now I have built my model. I've put it to the pipeline in terms of the whole life cycle. I also deployed as an endpoint, right? The need is to monitor my model. So in fact, the recent features helps you set up dataset monitors and then monitor the data drift. How is the data model has varied based on the data which was trained and for the data which is coming today. So that kind of analysis can be done through data drift capability, which is recently available. And the other recommendation which is provided is ML flow should be used for tracking and logging the job metrics. That's something which is also need to looked at as part of the monitor activity. So once and as part of the this monitoring or the pipeline, you also have an option to send out those notification events which are happening in the pipeline or the model to a event hub, which can be then consumed by a downstream application. The other aspect is once the model is available in endpoint with a good Power BI integration, you could actually use those models in a Power BI dashboard. So that's an integration specifically available with Power BI and Azure ML. And whatever data is captured as part of the logging of the model or the monitoring of the model, those data can be actually pushed into a blob store. And that again can be analyzed using Power BI or an application side. So what you have seen right now is all the different components, right from development, orchestration, monitoring, how that can be captured, how it can be analyzed. Right? These are the components which helps us build the whole ML application in Azure ML. Now, if you look at specifically on Synapse, right? In Synapse also you have options to build your ML model, right? So in Synapse Analytics Studio with the notebook interface, you could actually write Python, Scala, .NET based application which can help you build a model. And those models can be deployed. Again, there are two options. Either you can train the model on Spark Pool, not deploy, train the model on Spark Pool, or the other option is you actually have the model trained within an AutoML capability on Azure ML. So the Azure ML workspace can be integrated within Synapse ML, and then you can actually invoke an AutoML service from Azure ML to train the model. So now, once the model has been built and trained, now it has to be deployed. So one of the again, you can deploy the model in Spark Pool or on the dedicated SQL pool. But I think the popular method which we have seen is deploying the model on the dedicated SQL pool as part of a table. So basically, once you deploy in dedicated SQL pool, then it becomes a table which can be consumed using T-SQL predict, right? So now I have developed, I have trained it, I have deployed it, and I also have data which can be an input for the whole model, right? So now here in this case, we look at more DevOps and GitHub being leveraged. So unlike the pipelines which were used in the earlier, here we could look to use DevOps pipelines to do the actual and move the code. Scripts which has been developed in Notebook can be moved into GitHub, and it can be managed within DevOps pipelines in terms of code deployment or versioning or ensuring the training activity or actually deploying it on the dedicated SQL table as well, right? So what I've seen right now is the components which are available within Synapse ML for us to develop, train, and deploy, and how it can work with a DevOps GitHub kind of tool set for MLOps, right? So with this, we have seen importance of MLOps, what is driving MLOps, And then we have seen what are the tools available for us within Azure to build ML models, capabilities of MLOps. We have seen what components Azure ML provides, and now what components Synapse ML provides, right? So with this, I would like to hand it over to Ravi, who is in the call, for a quick demo of MLOps. So he will also take us through the MLOps architecture, and then take us through a quick demo of how do I build MLOps on a Azure ML environment. Ravi?
Sure, Panyan. Able to see my screen?
Yes, yes, Ravi.
Yeah. Thanks, Panyan. So before going into the actual demo, I just want to give you a flavor of how the architecture of setting up a MLOps on Azure ML looks like. So basically, we'll have these kind of three environments: dev, QA, and production. So all the development activities, like getting the data from the blob storage, building the model, creating the ML pipeline, and then kind of publishing the pipeline, and all these activities will take care in um, dev environment. And then once the pipeline is published, then the development activities can take place in QA, wherein we are going to deploy the model as a Kubernetes container, and then we are going to generate the endpoints. Once the model is deployed, then we are going to get the endpoints in Azure ML, which we will be looking in few minutes. And similarly, we can replicate the same kind of environment in production, and we can also look at monitoring the model, like for example, kind of detecting the drift in the data. So there is a dataset monitor service which is integrated as part of Azure ML, which gives us power to identify if there is any data drift. It also helps us in generating emails, triggers. If there is a data drift identified, there is a threshold where we can put the threshold, like say 20%, 30%. If there is a data drift, the magnitude we want, we can set the threshold, and accordingly it will give us the alerts, and we can also configure the triggers in order to retrain the published pipeline. So all these things we will be looking soon in terms of demo, like how we are going to do it, how to publish, and how to kind of create a data drift and deploy it and other stuff. So this is with respect to the Azure ML. Now, how this kind of ML framework works in Synapse? It's a little different when compared to the Azure ML. So there are multiple options where we can implement ML as well as ML ops in Synapse, like Pandian mentioned. One is using the notebooks approach. The other one is using Azure ML by linking it. So in both the cases, we the development happens in notebooks in case of notebooks approach, or Azure ML or Azure ML Studio in case of Azure ML approach. And we can create pipelines with respect to by using the Synapse integration component. We can create the pipelines, and we can use the created notebooks or the ML pipelines that we have created, and we can orchestrate it in order to do the continuous integration and deployment to be followed. And the scoring can be done using the T-SQL, unlike like how we do it in endpoints in Azure ML. We can do the scoring based on the T-SQL. That is something which is different when compared to the other platform like Azure ML or Azure ML Studio. So what we'll be covering in the demo, we are going to see how we are going to create the model, and creating the ML pipeline, and then publishing the pipeline, and then deploying it, and then consuming it as an endpoint, and then creating the data drift pipeline, and monitoring the data drift, and create triggers based on the pipeline. Okay. So now let me quickly move to the demo. So once we log into the Azure portal, then this is where we see all the workspaces that we have created. Iris is this is my Azure ML workspace that I have created, and I'm launching it now. So as Pandyan mentioned, there are different ways to implement ML and MLOps in Azure ML as well. So this is the Azure Machine Learning Studio that we are looking at now. So one is using notebooks, the other one is using automated ML, and the third approach is using designer. So I mean, the way we are implementing, or the way we are building our models, MLOps depends on that. So one option is when you use the automated ML, everything will be taken care. Like automated ML uses ML flow, which takes care of auto deployments and then model tracking and everything. The other approach is to use the Azure DevOps, create pipelines in Azure DevOps, and use Azure ML in order to uh, do the end-to-end ML lifecycle. The third option is use the designer, where you are again going to create the Azure pipeline workflows. These are a little different to what the pipelines that we see in Azure DevOps. That also we are going to see what is the difference. Okay. So I'll just kind of to start with, I'll just show you how this designer, we are going to look at the way we are going to build MLOps using the Azure designer. So once we go into the designer, we can create a new pipeline. I'm not going to create a pipeline because keeping the time in mind, I'll just show you I just want to give you the flavor of how it looks like. So here the data and components is available. All you need to do is just drag and drop here and connect the nodes, so that it is going to based on the flow uh, that we want, we can create these pipelines. Now I quickly jump to the pipeline that I have already created for the demo purpose. So if we look at this pipeline, so this is what I have the data, and then I have a column selector, and then I have the train test split. All these nodes that you are seeing, right, these are pre-built and available as part of pipeline that I have shown earlier, like where we have the data and components. So components with respect to machine learning are available in the components section, and whatever the nodes that are related to data are available in the data section. Okay, so this is how we are going to create the pipeline. This is my ML pipeline that I have created, where I have taken the data and selected the columns, and then split the data, built a multi-class decision forest, and then trained the model. I have scored the model, and then I have evaluated the model as well. So once this whole process, this pipeline is successfully executed, and the results are in place, then we can publish this pipeline. So once we click on publish, it is going to uh, ask us whether we want endpoint on what different inputs that are required. Like say, suppose if we want to define a new data node that is available for this pipeline to consume, all those things can be given as parameters, and then we can publish this pipeline. So once this pipeline is published, it is available for consumption. So now I have created and published my pipeline. Then now I need to consume it in order to deploy my model. Okay, so for that I have another pipeline, where I am going to show you how I'm going to deploy this particular model. So this one, the MD pipeline, this is my machine learning pipeline that I have created in the earlier step. So this, I am going to use it in this pipeline, and I'm going to deploy it. So in this particular pipeline, I have used I'm manually entering the data, as well as I have provisioned to get the data from a web service. Like say, suppose from some website, we can get the data in some tabular format, or whatever the format it is. We can integrate different uh, data sources, and then I have a column selector and then scoring model. Once the model scoring is done, then I am throughputing it to web service as an output. Okay, so once this entire flow is set, and once this pipeline is run, I can deploy it. So I have a couple of options while deploying it. So once we deploy it here in Azure ML, we are going to generate the endpoint for consumption, for business consumption. So we can deploy it as a Azure Kubernetes service or a container service, depending upon the environment that you are using. So actually we can do it in a separate environment, but for the simplicity purpose, we are showcasing it in one environment, but we can have 3 different environments, like I have shown in the architecture. So if you're deploying it in QA, you can use Azure Container Instance, and if you're deploying it in prod environment, you can use the Kubernetes service for deployment. And once you hit the button of deploy, it is going to create a job to deploy, and once the deployment is done, then the endpoints are available. So this is where we are having our endpoints. If you look at this, this is so I have already deployed this model, and I have already created an endpoint for our demo purpose. So this is how the endpoint looks like. So this endpoint can be integrated as part of any web service, or it can be used for testing purpose, or API testing, or it can be integrated into any API. So now we have uh, created a ML pipeline, we have published the pipeline, and then we have deployed it, and we have the endpoint for consumption. Okay, so what next? Next comes the drift. So how, say suppose if there is a change in my data, then how I'm going to, my model is obviously going to get affected. So if there is a new data which is coming, and that data is a little different than what I trained, then my model is going to get affected. So how I detect the drift in such instance? So if we look at this, Azure ML Studio provides a option of dataset monitor, which will help in creating data drift. So I just give you a flavor of how to create this drifts. I'm not going to create it. I have already created one data drift for our demo purpose. So if you look at this, so in order to create a data drift, we need two different data sets. One is the baseline data, and the other one is the target data. So baseline data is the data that we used for our model. Target data is like, the data that we get on a daily, monthly, weekly basis, depending on the frequency that we train our that we score our model. Say suppose 3 months back I have built a classification model, and every month I am going to score, I'm getting new data, and I'm scoring that based on the model that I have deployed. So in this particular instance, the baseline data is the data that I have used 3 months back that I trained it, and the target data can be the current month data or the previous month data, which I can use against my baseline data in order to see the drift. Okay, so once we define this baseline and target data in monitor settings, we can actually choose the threshold, and so that it will identify if a particular if it crosses a particular threshold, then how we are going to deal with that. Okay, so now let's have a look at whatever the drift that we have created. So if you look at this particular screen, this shows the data drift that is there in my model. So I have put a threshold of 20%, and for our demo purpose, I have simulated the data into different weeks, and this particular data drift is comparing the baseline data along with my data that I have got yesterday and today. So this is where we are going to see what data drift is happening, and what is the magnitude of the drift that happened, and which are the features that are impacting, top features that are impacting. And if we go a little down feature wise, it is going to tell me like what are all the different features that are affecting in what way and all. Okay, so this is how the data drift is identified, and in order to trigger we can create trigger based on the magnitude that is defined using Azure DevOps or CLI, which is available, or we can set once we get the so this there is an option of getting email triggers from the data drift. So once we get the email triggers, also we can check what went wrong, and we can actually retrain the pipeline manually as well. So this is from the Azure ML perspective. Now let me quickly move on to the Synapse. So this is the landing page of Azure Synapse Studio. So we have different components here: data, develop, integrate, monitor, and manage. So as I mentioned, like there are different ways in order to build MLOps here. So one option is to develop through notebooks here. So if you see here, we have already I have a notebook in place which kind of shows you, gives you a flavor of how it looks like. Okay, and the other way is to link the Azure ML inside the Azure Synapse. So for example, here um, uh, in the link services, I can go to the new service, and here I can search for Azure ML, and I can link it over here. Post which I can use the Azure ML service in order to build my models. Okay, so once we have these services in place, we can build the models. I'm not going into the nitty-gritties of it because our major focus is on building MLOps. So once we have these services and models built using either Azure ML service or notebooks approach, what we can do is we can create pipelines based on these notebooks, and that will kind of serve the purpose of CI/CD. Say, so when I go for pipeline creation, I have the option of bringing all these components into my pipeline. Say, for example, um, I want, say, I want to bring, I want to use machine learning. Okay, so here I can actually bring the machine learning part of it here. Okay, and then in the settings, I can go to the pipeline that I have already built, and I can schedule this pipeline in order to run based on the need that I have. So I can actually select the Azure ML that I already have. I can select it, and once I select it, I can see all the pipelines that I have built. Okay, so just select the pipeline, and then you can if you want to add a trigger, you can add a trigger, or if you want to add a trigger, what it will do is it is kind of a scheduling kind of a thing, whereas if you want to run instantly, you can go for the debug option. Similarly, we have in Synapse we have notebooks also. So if you can bring the notebook here, and uh, this notebook, we can schedule it to run here. Say suppose, imagine that this notebook is having our ML model. I can select that particular notebook, this particular notebook here, and I can schedule this particular pipeline to run. Okay, this is how we can orchestrate um our. Hello, am I audible?
Yeah, Ravi, you were off for a few seconds, but you are audible
Okay.
right now.
Okay, sorry. So I'm just saying, like, this is how we can bring in MLOps into picture by orchestrating the pipelines using either the notebooks or the machine learning service that is already linked for this particular Synapse space. And I also just want to give you a glimpse of how Azure DevOps pipeline looks like. Okay, this is a bit kind of different than the pipelines that we have seen in Azure ML. So using Azure DevOps and Azure ML, we can create the MLOps framework where the CI/CD, everything will be taken care by Azure DevOps, and the model building is taken care by Azure ML. So if you look at this, I have already pipeline created in Azure DevOps. So let's take a look at this pipeline, how this looks like, and what all it kind of shows us. So I have different runs for this pipeline. Let me edit any one particular run and show you how this pipeline actually looks like. What are the components inside this pipeline, and how MLOps will be taken care by scheduling this pipeline. Okay, so if you look at this pipeline, I have added all the required components as a job inside. So I'm using Python, and I'm using CLI, Azure CLI for a few of my um, DevOps work. And I also got in a kind of Azure Blob to get the data. And then here I am building the model using Azure CLI, and then I'm registering the model. For that also I'm using Azure CLI here. And I'm just publishing the pipeline artifact using this model. So this is how we are going to create the pipelines here. And once we create the pipelines, we can actually deploy the pipeline. We can publish the pipeline and we can deploy it. We can have triggers on this particular pipeline in order to automate the execution of this. And similarly, we can deploy it. And once we release this pipeline, that's where it is moving. It is going to move into a kind of QA or prod. So when you move this, when you release this, what happens is it is kind of getting deployed into another environment. You can use it. You can use a Kubernetes, or you can use Azure ACI container. So I have stopped this, container creation. But what I did is, out of the pipeline that I have created, I have manually triggered it and I have it executed, and then I have deployed it using package the model as Azure Container Service, and I have deployed it in the QA. So once this deployment is done and container is created, we will get endpoints for our consumption. So this is how we can, at a high level, we can use Azure DevOps along with Azure ML in order to train the model and create MLOps framework. So we can also create custom monitor, custom drift, data drift and monitor here using the Azure ML, using Azure ML code. So that's it from my side. We'll take questions, any or if you have any points to discuss. I would like to hand it over to Pandyan for further discussion. Pandyan, over to you.
Yeah, thanks, Ravi. You want to make me the presenter, Ravi?
One second.
Just did it. I just did.
Yeah. Yeah. Okay. Thanks, Ravi. So now we will look into, once I've decided to build my MLOps process, right? So what are the considerations? What should I look as my scope of work? Now let's look at that. So the first step is to understand what all components I'm going to build, or what are the things which I have to look for as a scope of work, right? So one is we could look at it in terms of five components or 5 areas which has to be looked at for me to build up an MLOps environment, right? So one is the architecture, what service I'm going to bring together, what is the current way of working, developing, how that is going to get enhanced or replicated in my new environment. So putting together the complete design in terms of what services I'm going to use to build the whole MLOps component. That's the design architecture. Second is, once I've designed the architecture, I've designed what services I'm going to use. I'm going to use MLflow, I'm going to use DevOps. I'm going to use some amount of the Azure CLI capability. So then how do I bring all those services set up for me to actually do my development work? That's the environment setup. The third aspect is data management, code management, model management is what we saw earlier in terms of capabilities. So in fact, each of these capabilities can be built separately. So that's why we're calling them as 3 different scope items, right? So data management is getting the data prepared or making it available for training and testing the ML models. So that's basically how I version the data. So you could actually have separate set of process tools for data management. So in fact, you might have certain things built in Azure Data Factory as part of data management. Code management is whatever code am I going to use, AutoML capability, am I going to use notebooks, how am I going to version the code, in what form I'm going to manage the code, right? So that's the code management. And the third is the model. So once I have the model, how do I version it? How do I do a release management? How do I deploy it? So those, so and for each of this, there could be, so for model tracking, I might use MLflow, right? So for training, I might use the DevOps process. So my development work in model management might be related to DevOps, or could be towards MLflow, right? So basically, what toolset I'm going to use for model management, code management, data management is going to decide my scope of work, right? Now let's look at the aspect of, for me to develop these components, the scope items, what are the considerations which will ensure that my implementation is successful, right? So one is to understand the current ML maturity. So how mature is my existing machine learning process? What are the existing tools which the team is using? So a good understanding of the current state really helps ensures that my MLOps is successfully adopted. Second aspect is whatever process which I'm going to build, the basic foundation should be to ensure that I'm able to reproduce the same activity again and again for a given data set. So ensuring the model is reproducible is built in a process which is reproducible is very important. The third aspect, which is also a basic foundation for MLOps, is automation. Right, whatever tasks I'm going to do should be completely automated. So that's also very critical. And this will ensure that the whole process, I'm sorry, so the whole process which I'm going to build is completely automated, and I'm able to bring in the automation in order I'm going to develop. The next thing is in terms of how do I deploy it, right? When I'm going to deploy my components, how am I going to make it scalable? How do I ensure that right compute are being leveraged? Right, and I'm able to monitor and also revisit those scalability components as and when required. And how I'm going to bring in compliance in my whole model management process. How I'm going to monitor my data drift and ensure those are aligned with my business function and expectations. And the other critical aspect is, especially if you already have an existing data scientist team working, how do I upskill them? How do I evangelize the whole process? How do I encourage them to leverage those frameworks and principles? So these are the different factors which needs to be ensured that along with the scope of work, we are looking all of this as part of my execution process to ensure that the MLOps process which I'm putting together sees success in the adoption. Right? And so for the whole scope of work and the considerations, what is the life cycle which I have to go through in terms of implementing it? So one is definitely what we saw, maturity assessment, ensuring that I have a good grasp of what's happening currently, designing the whole architecture, and then setting it up, right? What are the services required? And as part of my maturity assessment and RT setup, I should have actually identified a use case. If it could be an existing model or probably a new model development, which will go through the whole life cycle in terms of data management, code management, model management, the life cycle of complete MLOps process, which is what is MLOps implementation is. That's the pilot solution which I'm going to build, which I'm going to bring in all my capabilities. Not necessarily it has to be all the capabilities as well. So probably it could be out of 10 out of 14 capabilities I want to bring in as part of this 4 weeks MLOps implementation. Once that is done, then after that is where we get into the complete onboarding process, wherein probably this could be a one single model. From the next onboarding phase, the fourth phase is where actually I start bringing all the different models into my environment based on the framework which I built in the third phase. Right? So once that I have been able to go through all the 4 phases, that's where then actually this MLOps becomes embedded into the existing environment. So let me also quickly talk about one of the success story where we have actually leveraged a combination of Azure ML pipeline and Azure DevOps pipeline to actually bring in a MLOps process into their model development activity, right? So this was a specific use case where we had a combination of Azure ML and cognitive services for image classification for animal health, for predicting animal health condition, right? The challenge was here to we also had a lot of custom process scripts running on logic apps. So we need to ensure that's the reason why we had a DevOps, which is a combination of tool sets to build the complete framework. So this actually brought in a lot of value for the whole organization in terms of how this can be replicated, this whole process of MLOps from this complex process where multiple services are used to a much more simpler where only pure Azure ML was leveraged in other business units within the organization. So this became a good testing ground to validate multiple scenarios to build MLOps process framework. Now, how does WinWire help, right? So in customers who want to adopt MLOps. So we have Win MLOps as a framework which brings in tool sets, model patterns, and best practices to our and deployment options, because there are multiple tools like what you see, the ML flow, we have DevOps, we have Azure ML, there are certain components in Synapse. How do we bring all of those things together is what Win MLOps is. We bring this to our customers to accelerate the whole MLOps adoption process. And as part of this, we also bring in a lot of toolkit, especially if you have to assess your environment or build a business case. We have tool sets which makes things quicker. And We also have a offering right now in Azure Marketplace to help customers quickly do their POC in a 4 weeks time frame to realize the value of MLOps. I think with this, I've kind of covered what we want to talk about, implementing MLOps effectively. Noor?
Thanks, Pandian. Thanks, Ravi, for taking us through the session. We are almost at the tail end of this session, but in the interest of time, what I would still like to do is, there are a bunch of questions, but probably we'll cover a few right now. So this, Ravi, is for you, coming from Bharat. Basically, what it is asked is, how do you decide on compute targets? Is there any specific way that we can decide on the compute targets?
It depends on the complexity of the solution that we are going to build, like the volume of the data and the frequency of the model refresh. Considering all these things, we need to look at the compute should be small, medium, and there are options for scaling up. So you can start with a medium compute, and maybe if you are doing a POC kind of a thing, you can start with a medium compute, and if at the once you move into production and from POC mode to full-blown solution mode, you can scale the compute as well. There are options available. So if you ask me how you decide upon it, that completely depends on the complexity of the solution that you are going to address.
Sure. So the one more question is, can you elaborate on what test you perform to calculate drift other than using drift monitor?
The question, Noor, what is?
Okay, can you elaborate what test
Yeah.
you performed to calculate drift other than using the drift monitor?
So for one of our clients, we used distributions. We try to compare the distributions, and we have also used the Nani ML package, which actually calculates the drift based on the chi-square test. And yeah, mostly we go with the distributions, like the data distributions, univariate, multivariate, probability distribution function. We use these things.
Okay, perfect. So the other question is, like, how do you perform load testing and infra testing, Ravi?
So with respect to the testing, like if it is in the QA environment, then depends like what framework that we are using, and infrastructure environment, we are going to perform it using the different components that we are using, and it also again depends on the complexity that we are addressing here.
Okay, great, thanks. Pandyan, this is for you. For building the MLOps process, do we need DevOps or Azure ML or ML Flow?
Okay, yeah, I think this might be a confusion for many of them. So definitely a combination of toolset is what we have to look at, and again, it depends on if you have built all your models using Designer, and you're looking at only model management as your starting task in the overall MLOps process, then Azure ML pipeline should be good enough, right? But if you're looking at code management and you have written a lot of scripts, then probably a part of DevOps will come into picture. And ML Flow, definitely even Azure recommends that. ML Flow is recommended for tracking and the model metrics and logging it. So that's where you will ML Flow will come into picture. So a combination of tools, and again, where we want to start in the overall maturity will determine what tools we have to use.
Great. Thanks a lot, Pandyan and Ravi, taking for those questions. I know we have few more, but in the interest of time, what I would like to do is we would like to take some of those questions offline. Folks, whoever is joining, if you have any further questions, you can certainly drop us a note at marketing@winwire.com or like even on this chat window. What we will do is we will take some of those questions offline. Okay. Ravi and Pandyan, thanks again for taking time to deliver the sessions, and thanks everyone for taking time to join the session, and hope you found it informative and useful. We will share the recording in next 24 to 48 hours. Thanks everyone, and have a very good day.
Thank you.
Thank you. Thanks, everyone. Bye.